Dear students, I am Rajarama from Srimati Indiragandhi Government First Grade Women's College Sagar, Shivamogga district. I want to explain one topic in the subject Techniques for Business Decision Second of the Kuvempu University. The topic name is Statistical Quality Control. First I introduce the topic. Nowadays of competition, businessmen are very much worried about the quality of the product. If they maintain the quality of the product, they have their own customers. On the other hand, if they fail to keep the quality according to the standards required, they neither retain the existing customers nor the new customers. Hence, they have to maintain the quality of the product. Therefore, they always go for employing the quality control techniques. What is new now is the application of the statistical quality control technique for maintaining or keeping the quality of the product. What is that statistical quality control? The statistical quality control is the statistical analysis of the inspection data based on the sampling and principles involved in the normal curve. In other words, it is the getting the data from the manufacturing process and the analysis of the same to know about any quality variations. For the first time, such a technique was applied by the W. Govt, who was working for the Bell American Telephonic Company and studied the variations in the quality of the components. Usually in the business organizations, regarding the quality, there are the variations in the quality at the time of manufacturing process. Here, statistical quality control applies to the variation in the some measurement of the products produced. The quality here means the measurement variations. These variations in the manufacturing process may be of two types. One is chance variation and second one is the assignable variations. The chance variations are the variations of the quality product because of the random reasons or regular reasons. These reasons are inevitable and unavoidable, and even the variation will not affect much to the quality of the product. On the other hand, the assignable variation may occur due to the non-random reasons, occasional reasons, and these reasons actually they affect the quality of the product. Usually these reasons include poor raw materials, wrong machine operation, wrong setting of the machines, breakout spare parts of the machines, likewise. Therefore, such causes will lead to the the quality variations, and therefore those factors should be identified and controlled. Otherwise, the quality product may be lost. Next, I go to the control charts. In order to study the statistical quality control, it is necessary to prepare a control chart. The control chart is a graphical device which is used for presenting the data obtained from manufacturing process and then analysis, and to see that whether there is any variation in the quality of the product, and that too whether it is a chance variation or assignable variations. Therefore, control chart is prepared on the graph and to be understood to see that what is the quality variation. This control chart is prepared by taking into three horizontal lines. They include first one, the central line or average line, and second one, upper control limit line, and third one, lower control limit line. So if these three lines are drawn on a graph, and then we can see that whether there is any quality variations. In order to observe the quality variations, it is necessary to plot the mean values against the number of samples. And then see that if plotted points are within these control limits, the process is said to be under control. The manufacturing process is said to be under control. On the other hand, if there is any plotted points go outside the control limits, the manufacturing process is said to be out of control, and steps should be taken to find out the reasons for the variations, and corrective steps should be taken into consideration. Therefore, there are two types of variation in the quality. There are chance variation and assignable variation, which can be plotted on the control chart, and one can study the quality variations. Then there are two types of control charts are there. The first is control chart of variable, and the second one is control chart of attributes. The control chart of variable is related to the characteristic features which are capable of direct quantitative measurement. On the other hand, control chart of attribute is used for studying the characteristics which are not capable of direct quantitative measurement, but their presence or absence can be counted. That is known as control chart of attributes. There are different types of control charts are prepared. They include mean chart, range chart, C chart, P chart, etc. This mean chart and range chart are the examples of control charts of variables, and C chart, P chart are the examples of control charts of attributes. Now I explain what is this mean chart and what is this R chart or range chart. Mean chart is the chart which is used to show the quality averages of the products obtained from the given manufacturing process. For the construction of the mean chart, we need to calculate 6 important values. They are mean of samples, mean of sample means, range, mean of range, upper control limit and lower control limit. This mean of sample is nothing but the value calculated by totaling the X samples divided by the sample size. The formula is X bar equals sigma X divided by N. N means sample size. Secondly, mean of sample mean is the value calculated by applying a formula X double bar equals sigma X bar divided by number of samples. Sigma X bar means the total of the mean values. Total of the mean values. X double bar means mean of sample means. Then we have to calculate range. Range is nothing but a difference between the largest sample and the smallest sample. The formula is R equals L minus S. Then we have to find out the mean of range. That is by a formula R bar equals sigma R divided by N, number of samples. Sigma R means total of range values. That is number of samples means maybe the sample values, not the sample size. That is to be considered. Then upper control limit value. Upper control limit value is calculated by a formula UCL equals X double bar plus 3 sigma X bar. Here sigma means the value calculated by dividing the standard deviation by the square root of N. N means sample size. The formula another is used to calculate the same upper control limit. That is UCL equals mean of sample mean, that is X double bar plus A2 range bar. A2 is the value which is calculated already in the tables that can be used for calculating the upper control limit. Similarly, next calculation, last calculation is the lower control limit. The lower control limit is also calculated by a formula LCL equals mean of sample mean minus 3 sigma mean, or Another formula is use LCL equals x double bar minus A2 range bar. By getting these values, we can prepare a mean chart. So after calculating all these values, you go to mean chart where you draw a 3 horizontal line. First one is the average line which is in the middle, and upper control limit in the top, and lower control limit line in the below the central line or average line, and plot the values of mean values against the vertical number of samples, and see that whether plotted points are within the control limits or outside the control limits. If the plotted points are outside the control limits, then the process is to be said to be out of control and reason should be calculated or found out. That is about the mean chart. Lastly, I concentrate on the range chart. What is that R chart? R chart is the chart prepared to show the variability or dispersion in the quality of the product produced in the manufacturing process. This can be prepared by calculating the 4 important values. One is range, second one is mean of range, third one is upper control limit, and fourth one is lower control limit. Range and mean of range values are calculated in the mean chart by following the same formula. Here, upper control limit is calculated by a formula UCL equals D4 range bar. D4 is the value which is calculated already available in a particular table that has to be used. Then, last one is lower control limit formula LCL equals D3 range bar. What is that D3? D3 is the table value calculated available in the table. This D3 value is 0 up to n equals 6. Therefore, using all these values, we can prepare the range chart. So, range chart is prepared by having 3 horizontal lines. One is central line or average line, that is range bar, R bar is used. Then upper control limit, then lower control limit below the average line. And then plot the range values against the number of samples. And after plotting the values, you see that whether plotted points are within the control limits, either UCL or LCL, or outside the control limit. And if they are within the control limit, the manufacturing process is under control. If they are outside the control limits, the manufacturing process is said to be out of control, out of quality control, and steps should be taken to find out what are the reasons for the variation or dispersion in the quality. So that is about the preparation of the range chart. So that I covered the important topic in the strategic quality control: introduction, meaning, control chart, types of control charts, and mean chart and range chart. I hope you have theoretically understood the topic statistical quality control. Thank you. Now I close the topic. Thank you all.